Welcome back, everyone. Let's dive straight into more calculations, okay? So, now we're going to do a bit of a case study with it. A car travels on a long, straight road. All right, so we've got a long, straight road, horizontal. Its velocity is recorded every second. So what you can see here is time zero, it didn't have a velocity. Then every second, they're recording instantaneous velocity. Now, I want you to see something. As we look at it, the first velocity, okay, that's 0. Then it's at 4 meters per second, and now it goes to 8. The difference between those two numbers is 4, okay? Then it went to 12. The difference between those two is 4. Then it went to 16. That difference is also 4. Then it went to 20. That's 4. Then it went to 24. That's 4. So if you look at it, every second, the velocity was increasing by 4 meters per second. So every second, velocity increased by 4 meters per second. So if I said what is the rate at which it's increasing by, you would go 4 meters per second divided by seconds. You know from maths, if I take that up to the top, it becomes seconds to the minus 1. So it's 4 meters per second. Oh, look at this. That's the acceleration of my car. It's accelerating at 4 meters per second squared. Every second, the acceleration is getting bigger by 4. So the velocity, is getting bigger by 4. So it's covering bigger stretches of distance in the same time period. It's getting faster, okay? What if now we go the other way around? So now look here, we have a car traveling on a straight road. Again, we record its velocity, but over here, even though time is 0, it's already moving. So the car was moving, and then as it passes a point, we start the stopwatch. So it has an initial velocity. And if you look, it's getting smaller. Let's see how much it's getting smaller by. So to go from 20 to 17, I had to minus 3. 17 to 14, we took 3 away again. 14 to 11, we took 3 away. 11 to 8, we took 3 away. 8 to 5, we took 3 away. 5 to 2, we get minus 3 again, and this would stop before the 7th second, okay? So what this is telling me is that my velocity is getting smaller by 3 meters per second every second. That means that it's 3 meters per second. But now we say, I'm getting a negative value here. How do we describe this? So I'm going to tell you that the car is accelerating. And right now you're all screaming at the screen going, no, it's not, Tracy, it's decelerating. Yes, in English, we would say decelerating. Not in science, okay? What it means is that there's a force acting on the car, the brakes, that's stopping it. So the acceleration is backwards. It's negative. It's getting smaller. So what we would say is this car's acceleration is 3 meters per second squared backwards. That tells me that the acceleration of my car and the velocity of my car are in opposite directions. So for the car to slow down, acceleration must be in the opposite direction, okay? Because there's a force that's stopping it from moving. Very important, okay? So negative acceleration just means it's in the opposite direction and my object will slow down. Please don't use the word decelerating. That's something we do in everyday language, but it's not actually a science word. So, cyclist starts from rest, initial velocity 0. After 7 seconds, she attains a velocity of 7 meters per second north. So, let's see what we've got. Starts from rest. Initial velocity, 0. Rest, not moving. After 7 seconds, so now my time is 7 seconds, she's going 7 meters per second north. Okay? I need a direction. Now they want to acceleration. Remember, acceleration is the rate of change of velocity. So acceleration is change in velocity over change in time. Rate, I'm just going to remind you, you don't have to write it in the equation, is final minus initial. Whenever I have that delta sign, the triangle, that means change in. Okay, so we take what happened last minus what happened at the beginning. It's always final minus initial. So, final, 7 minus 0 divided by 7. Okay, that means 7 divided by 7. 1 meter per second squared north. Because that was the direction of her velocity and she was getting faster. Now, she's traveling 12 meters per second west. So initial velocity, 12 meters per second west. She has to stop at a stop street. It takes her 10 seconds. And her final velocity is going to be 0 because she stops. They want acceleration. Whoopsie. So, acceleration, change in velocity over change in time. Final velocity minus initial velocity divided by 10. So let's just check. So we've got 0 minus 12 divided by 10. I get minus 1,2. We never ever leave it as a minus. We have to change it to a positive. I, by default, made west positive. So her acceleration is 1,2 meters per second squared east. So she slows down by 1 meter per second squared, by 1 meter per second every second. Okay, she's slowing down. All right, so all right, we have done a lot. Okay, remember about the direction of acceleration. Negative acceleration because it's slowing down, and the acceleration is in the opposite direction to which the object is moving at. Okay? Wow, we got through a lot. I hope it's all making sense to you, but we're going to stop there for today, and I will see you again next time.